This lecture is about topic mining and analysis. We're going to talk about its motivation and task definition. In this lecture, we're going to talk about a different kind of mining task. As you see on this roadmap, we have just covered mining knowledge about language, namely discovery of word associations such as paradigmatic relations and syntagmatic relations. Now, starting from this lecture, we're going to talk about mining another kind of knowledge, which is content mining, and trying to discover knowledge about the main topics in the text. And we call that topic mining and analysis. In this lecture, we're going to talk about its motivation and the task definition. So first, let's look at the concept of topic. So topic is something that we all understand, I think, but it's actually not that easy to formally define it. Roughly speaking, topic is the main idea discussed in text data. And you can think of this as a theme or subject of a discussion or conversation. It can also have different granularities. For example, we can talk about the topic of a sentence, a topic of an article, a topic of a paragraph, or the topics of all the research articles in the digital library. Right? So different granularities of topics obviously have different applications. Now, indeed, there are many applications that require discovery of topics in text and then analyze them. Here are some examples. For example, we might be interested in knowing what are Twitter users talking about today. Are they talking about NBA sports, or are they talking about some international events, etc.? Or we are interested in knowing about research topics. For example, one might be interested in knowing what are the current research topics in data mining and how are they different from those 5 years ago. Now, this involves discovery of topics in data mining literatures, and also we want to discover topics in today's literature and those in the past, and then we can make a comparison. We might be also interested in knowing what do people like about some product like iPhone 6 and what do they dislike, and this involves discovering topics in positive opinions about iPhone 6 and also negative reviews about it. Or perhaps we're interested in knowing what are the major topics debated in 2012 presidential election. All these have to do with discovering topics in text and analyzing them. And we're going to talk about a lot of techniques for doing this. In general, we can view topic as some knowledge about the world. So from text data, we can expect to discover a number of topics. And then these topics generally provide a description about the world. And it tells us something about the world, about the product, about the person, etc. Now, when we have some non-text data, then we can have more context for analyzing the topics. For example, we might know the time associated with the text data, or locations where the text data were produced, or the authors of the text, or the sources of the text, etc. All such metadata or context variables can be associated with the topics that we discover, and then we can use these context variables to help us analyze patterns of topics. For example, looking at topics over time, we would be able to discover whether there's a trending topic, or some topics might be fading away. Similarly, looking at the topics in different locations, we might know some insights about people's opinions in different locations. So that's why mining topics is very important. Now, let's look at the tasks of topic mining and analysis. In general, it would involve first discovering a lot of topics, in this case K topics, and then we also would like to know which topics are covered in which documents, to what extent. So for example, in document 1, we might see that topic 1 is covered a lot. Topic 2 and topic K are covered with a small portion. And other topics perhaps are not covered. Document 2, on the other hand, covered topic 2 very well, but it did not cover topic 1 at all. And it also covers topic K to some extent, etc. Right? So now you can see there are generally 2 different tasks or subtasks. The first is to discover K topics from a collection of text data. What are these K topics or K major topics in the text data? The second task is to figure out which documents cover which topics to what extent. So more formally, we can define the problem as follows. First, we have as input a collection of n text documents. Here we can denote the text collection as C and denote a text article as DI. And we generally also need to have as input the number of topics, K, but there may be techniques that can automatically suggest a number of topics. But in the techniques that we will discuss, which are also the most useful techniques, we often need to specify a number of topics. Now the output would then be the K topics that we would like to discover, denoted as theta sub 1 through theta sub K. Also, we want to generate the coverage of topics in each document, D sub I, and this is denoted by pi sub ij. And pi sub ij is the probability of document D sub I covering topic theta sub j. So obviously for each document we have a set of such values to indicate to what extent the document covers each topic. And we can assume that these probabilities sum to 1 because a document won't be able to cover other topics outside the topics that we discovered. So now the question is, how do we define theta sub I? How do we define the topic? Now this problem has not been completely defined until we define what is exactly theta. So in the next few lectures, we're going to talk about different ways to define theta.